Okay, guys. Let's look at page 30, number 7. So this is part of the questions for 1.3. Try to post as many as we can of those, because I'm getting to the realization I can't work all of them out in class. There's a lot of theory that goes with them. So we'll try number 7 right now. So we're asked to find the average acceleration of a sports car that increases. So let's write down what we are given. Increases its velocity. Okay, so I really like the subscripts number for describing those. So the starting velocity, we'll call it V1. Okay, so we'll go V1 vector, right? So velocity. So it's 2.0 meters per second west. Sorry, let me fix that. And V2 final, I could have called it V final. I could have called this V initial. It's okay. It is 4.5. Which direction is that? This is west. Okay, I didn't think about it yet. Okay, so I'm thinking about it live. Okay, so I'm literally recording me trying to solve it. Okay, so what do we do with this one? And we're told that this is done, right? So delta t, right, is 1.9 seconds. Okay, so this one, they're giving us a lot of info, and just because of the delta t, it basically screamed it at me in my head. This is going to be, to find the acceleration for that, we're just going to use the general formula. Okay, so acceleration is delta of your y, so in this case the velocities, over delta t. Let's break it down. Again, now in this case, it doesn't make much difference, again, which one we put as V1 or V2 first. We're going to have to watch for our signs, though. This is the part where math plays tricks on us. It is easier in this case to go V2 minus V1. Okay, so let me just write that. And the way I'm doing it, this is the way I would expect you guys to do it on paper during quizzes and tests. Okay, V2 minus V1 over, and we know delta t. This is why this one is going to break down pretty simple. So 1.9. As you work it out, for this one, yeah, you can put the units, but it's not super critical. Okay, so you just calculate that. Well, this is actually pretty simple. So it's going to give us 2.5, okay? 4.5 minus 2, this is 2.0. Okay, now I have to use my significant digits, so I'm subtracting. So I'm going to keep the 1 decimal spot. So I'm going to land on 2.5 meters per second. This is west. And this is over 1.9 second. I don't have a calculator handy. My phone is there, but like you guys can finish that at home or whenever. So you just calculate 2.5 divided by 1.9, and whatever that number gives, right? So this is equal, right? The answer goes here. Whatever that value is, you're going to get that value, but don't forget your units. So it's meters per second square. Now, that's an acceleration, so it's got a direction. You should put the west. Okay. So this is it. So that would be number 7.